Hello everyone, in this video we'll see binary trees. Subtree sum exists for x. We are given one binary tree and a number called x. For that number x, we have to find a subtree of sum is exist in this whole tree. For example, you are given a number called 17 is there, and you have to see in the tree this subtree gives me the sum of 17. So when you're picking up the node, you have to take all of the nodes coming below this root. So when I'm picking this 2, I have to take all this nodes. It's not a subset of nodes, it is subtree. So once you have picked up this node, then all the nodes which comes below this node, so should be taken into the account. Okay, here I have node definition, data, right and left pointer, and this is the code snippet of how do I'm going to approach this problem is written here. So it starts as subtree sum. It expects 3 parameters, namely node, current sum, expected sum. The first line is if the node is null, I have to return false. If it is null, no need to proceed further. And I have two variables called left sum and right sum. If left provides me the answer, I'll propagate it as a true or false, whether that left subtree having the sum and right subtree having the sum. You just need to print it exists or not, yes or no. No need of which node it starts, from which tree side it gives me the answer. Those are all not the scope of this problem. Only is whether it's there or not, yes or no. So what I do is I have with these two variables, I carry my iterations recursively in the right and left subtree, and I update my current sum using this right nodes what they returns as a sum, and the left node what they returns as a sum additional to that node's data. That's what this current sum equals left sum and right sum and data. And I have updated that sum in current sum, and I check that current sum is equal to the expected sum, then I'll return it as true. So at least here anywhere in this tree comes as true, then the whole tree in this tree itself it having some data. Here it directly returns for that 17, it returns this condition that current sum equal to the expected sum. But when you consider these nodes like 2 or 10, it just returns from the left side because it's recursion calls. Once this returns as a true, all this will be updated as true. So this left sum for these nodes will be returning it as true. So the whole tree contains somewhere in the tree subtree contains this given sum. So we'll run a dry run in this tree and we'll check this for this input. I'm going to check for this sum 160 whether it exists in this tree or not. If it exists, here you can see this. This is 160, this is 160 is there, and this subtree contains the answer. So here what I have is left sum, right sum and current sum, which will be passed to this root node, and with these three variables I'm going to address this code. Okay, initially this left sum and right sum is equal to 0, and this condition will not go inside. This contains data, this is not null, and it should go this 20 left side at for this line, whether it's going to check that whether this subtree contains this data or not. So what I do is I'm going to take this current sum, which will be passed externally at the time of calling this function outside this class, which means the int main function. Okay, now it goes to the left side, and which will be taking this current sum for next iteration. Here it's coming first, it would go to the left. So I'm going this left side. For this whole object, I should have a duplication of this when I'm calling a stack trace with the recursion calls. So my left sum will become the current sum of the next call. So I have to pass that it in current sum, and I'll update that in this current sum, and I'll check that. That's what this line is. When the next time it goes, it expect the left root of this node, and the current sum I have to pass this L sum, and I have to check, and the expected is nothing but the expected sum. These three arguments again I have to call. So again it will goes like this. So whatever I'm passing this left side, that will be updated in the LSUM variable, and brings me the answer. Whether that's there or not, here it will returns. Okay, now the next thing also, here it propagates as left sum. So here the current sum it calculates, and whether it next sum it's updates. Similarly, when you're going right side, it updates that in the R sum. So for this one itself, you have to go to the R side also. So what it does is, it duplicates when it is here. This right sum will update to the current sum. So there it will check. So here nowhere it's there that will not be uh, equivalent data. Here equivalency check, it will not pass. But when you are going to this right side, let me just clear this, and this arrows also. Okay, this left side iteration is done. I have this right side iteration, so I have to call this right side function. So what I do is, I'm going to call this function. So right sum I have to pass it as a current sum. Okay, now it should go deeply left and right. So when it goes here, I have to take this left sum, and I have to pass it as this current sum, and right sum I have to pass it here as a current sum. So like this kind of wiring up is done. Okay, here when it goes right or left, nothing is there. So what it retains is the current sum from this data. So current sum carries this 60. Here no conditions will pass, because this current sum expected sum it's checking, and it will not pass, and here also it's all false. Here the same case for 60 also, as 60 here left and right is not there. So what it gets is, it reads the data from the node, and it will update as 70, because here you can see this left and right, it all have nothing to do with that. So it's 70 it will take, and it propagates the 70. Okay, now I have this left and right, what it comes from my current sum. Okay, now updated in the current sum. So I have to add these three things now. In this line, as you can see, left, right, and data. So 60, 70, and 30 is added. So it's, next line it comes, it's equal to expected data. Yes, it is equal. So that time it is written as true. So all other places it will return as false, because no conditions will satisfy this. But when at only this edge will return it as true, but the whole problem will become true, because it's anywhere it can exist in this tree. Okay, now we can check with this one whether this one contains any answer as 100, sum as 100 is means, here you can check these two things. If you add it up, it will become 100. But this is nodes, it's not a subtree. So if you are picking up a node, what are all the nodes comes under that, it should take. So if you pick up 10, then you have to take all these things. That is not equal to this 100. So that's the reason it does not exist. You calculate this here, if you take this one also, it is 100. But if you pick this node, this 20, 30, 40, 60, everything you have to take. So okay, so that's the reason it is no. Here you can see this 110 as an input. If you pick this one, this subtree 50, you can see this 60, and this one, not this one, this whole tree. If you pick this whole tree, it can here 100 and here 110, so 210. I have to print the answer. Okay, now we'll implement this code snippet in Visual Studio Code, and how it look like we'll see. Here I have basic setup. I've imported all the statements, and here node classes there. I've added the public properties of data and right and left pointer. Here I have constructor, and in the main function body I have these three trees in a coded format. These three trees are written in this coded format, and we jump to program. Okay, now I have to return boolean, so bool. Here the function name I get it as subtree sum. It expects node root, and I need one pointer for current sum, so current sum, and I need expected sum, expected sum. Okay, if the node is null, I have to return false. Okay, now I have to write two variables, int left sum equals 0 and right sum equals 0. Bool. Here the left will come, answer will come, so I just keep L and subtree sum. So I have to write roots left, and here I have to give the reference of left sum. So whatever the current sum updated in future, that will be updated in this left sum variable. So expected sum, I have to pass the same expected sum. How to turn it to right, and here it is R, and here right sum. Okay, now I have to update my current sum as current sum equals left sum plus right sum plus my current data, so roots data. Okay, and here I have to return current sum equal to expected sum, or whether the request answer of this one results as true, that is written here, and here R. Okay, okay, my code is ready here, and I have to call, so cout in subtree sum, and here I have to pass n, and I need in current sum. So what I do is I declare one more variable p equal to 0, and I pass the address of that p, and I need one more variable as x. So what I do is I have to pass this x equals 160, which we have seen. So okay, now I have to pass the same thing for others also. Here I update this as m, and m must be passed here, and here also it is y. Okay, here I have to give answers 110, and here it should give us 100. Okay, now my code is ready to run. I have to run. What the answer I supposed to get is here. The first one, it is yes, and second one it is no, and third one it is yes. Okay, run the code. It is 101. 1 means yes and 0 means no. Okay, all our test cases are passing. Hope you understood the problem and solution, and thank you for watching this video. We'll meet in the next video.